Hello everyone, I hope you're just as excited as I am for this next section in the polynomial unit. So far we've been talking about how to expand and factor trinomials, right? We'd be expanding two binomial products, or we've been doing the inverse of that, which is factoring the trinomial. So we're going to expand on that, and we're going to start talking about a new strategy that we can use to factor complicated trinomials, which leads me to our title, which is factoring by decomposition. And this title will make a lot more sense here in a little bit. Decomposition just means to break down. So I want you to keep that in mind because we're going to be breaking down our polynomials, our trinomials, to help us factor it. So before we actually look at a trinomial and factoring it, let's look at the product of two binomials and see if we can notice some kind of pattern or there's some kind of relationship within that. So let's have a look at say 3x plus 4 times 2x plus 1. If we multiply our 3x, we're just going to go ahead and expand this. Our 3x times our 2x gets us our 6x squared. Our 3x times our 1 gets us 3x. Our 4 times our 2x gets us 8x. And then our 4 times our 1 gets us positive 4. And then we can go ahead and we can simplify this further by combining those like terms. We end up with 6x squared plus 11x plus 4, which is kind of nice. Nice little way of doing that. Just to remind you, the strategy I use to multiply or to expand these is called the distributive property. There's a few more videos on that. But anyway, moving on, what I want to look at is kind of a nice little relationship that happens within this part right here, this kind of broken down or decomposed part of this trinomial, right, before we simplify it. And what I want you to notice is that if you multiply the 6 and the 4, 6 times 4, right? 6 times 4, that actually equals 3 times 8, right? They both equal 24. That's a really nice kind of relationship that happens there. And if I was to use any other example, you would see the same thing, that when you just have this separated out, when you have the trinomial separated out into, you know, all of the terms, right, by using the distribution method or the rectangle diagram, whatever, you will realize that if you multiply the coefficient of the x squared by the constant, you will get the same product is if you had multiplied the two coefficients of that x term. Now, the other thing to keep in mind here is that, yes, 3 and 8 multiplied to get you 24, they also add together to get you that middle number. So that's important to remember as well, right? Because we need to find a way to go from here and work our way backwards. So all of those relationships are important to remember. So let's use that knowledge and let's do a nice little example here. We're actually going to make it a little bit more complicated. So I want to say factor, and we are going to do kind of a difficult one. 3x squared minus 13x minus 10, right? We're going to use decomposition, right, to factor this. And I haven't actually shown you what that is yet, but you'll kind of see how it's the backwards version of this. So remember, first things first, we know that we want to find basically this number here and this number in here, right? We need to figure this part out here. And what we're going to do is, well, we know that whatever those two numbers are, they will multiply together to equal the same thing that these two multiplied together. So we're going to multiply our 3 and our 10, right? We're going to multiply those two together, and 3 times minus 10 rather is going to get us minus 30. And we want to list the factors of minus 30. So we'll start off over here, factors of minus 30, right? And we have similar to my last video, I'm just going to list the factors of 30, and we'll have to keep track of the fact that one or the other could be negative to satisfy that minus 30. So 1 and 30, 2 and 15, we have 3 and 10, and 5 and 6, right, for factors, right? And either the 1, 2, 3, or 5 is negative, or the 30, 15, 10, and 6 is negative. Again, it really depends on the situation. We'll figure this out here in just a second. So the other thing that we need to satisfy is that when we combine two of these factors, we get minus 13 as a result. So we need to find two numbers that combine together to get us minus 13. Now keep in mind, one of these sets of factors, when we combine them, one of the factors in each of these sets is negative. So I know it's easy to look at 3 and 10 and be like, well, that's 13. It's not negative 13, and one of these has to be negative. So negative 3 plus 10 isn't 13, it's 7, or 3 plus negative 10 is negative 7, so that won't work. But if we go down through the list here, I mean, the 1 and 30, no matter which one's negative, you're going to end up with either 29 or negative 29 there. The 2 and the 15, if we have that as a negative 2, negative 2 plus 15 gets us positive 13. We don't want positive, we want negative. So I'm just going to undo that. If we make it 2 plus our negative 15, that gets us our negative 13. So there's the two numbers of interest right there. So we know when we break this down, when we go backwards a little bit, we could actually say, well, that's like 3x squared, right? I'm kind of going backwards, similar up here. And that negative 13 can be broken down into plus 2x minus 15x, and then our minus 10 stays the same. Right? So that's how we can decompose this into a more expanded form that's going to help us proceed, right? That's why this is called decomposition, is this step right here where we break it down. Remember, that's what decompose means, is to break down. Now, we're not done yet though, so it's still kind of unclear probably how we can get from something that looks like this to something that looks like this. And that's where we're going to get into our next step. Now, this part here is kind of cool. What we're going to do is we're going to look at each pair of terms separately. So what we're going to do is we're going to combine our x squared and an x term, and then we're also going to combine the other x term with the constant. We're going to break these up into two different worlds here, and I'm actually going to use a different color to make these a little bit more clear. Let me undo that. Right, we're going to look at these two sets kind of individually, and what we're going to do is we're going to remove a common factor from each set of those terms. So what that means, let me get my orange up here, is for the orange, this is all, I'm going to give myself a bit more space. For the orange, if we look at, well, what terms does 3x squared and 2x have in common? Well, you can factor out an x from each of those. 3x squared divided by x is just 3x. 2x divided by x is 2. Not too bad. Now we're going to look at the second set, and we'll get out our blue here. 15x minus 10. 5 or minus 5 is a common factor between all those, so we could factor out minus 5. And 15 or negative 15x divided by negative 5 is going to get us positive 3x, and then negative 10 divided by negative 5 gets us plus 2. And what you should notice here, this is kind of cool, is that this and that are the same number. Now, with negatives, it's a little bit trickier. If I didn't factor out negative 5, if I factored out plus 5, then my signs would be flipped. So I'd still have 3x and a 2 in there, but it'd be negative 3x negative 2. So it's important to realize that the that the magnitude or these values will be the same, except for the signs might be flipped. If the signs are flipped, just factor out the negative version or the opposite sign version to get whatever's inside those two brackets the same. Now, this is where it gets kind of cool, and this is where math is like magic to me, is that what's inside the brackets is actually one of our binomial terms. The numbers outside the brackets, you combine them to get our other binomial terms. So this actually equals x minus 5, right, times 3x plus 2. I got the x minus 5 because x minus 5, and then the 3x plus 2 from what's inside the brackets. And that's it. That's how we factored it. I think that that is absolutely magical. Now, we can go ahead and expand this. We can check our answer by expanding it. I'll see if I have enough space here. So if I go x minus 5 times 3x plus 2, that equals, well, x times 3x is 3x squared. X times plus 2 is 2x. Minus 5 times 3x is minus 15x, and then minus 5 times plus 2 is minus 10. This line here should look pretty familiar because it's this step right there. So we know our decomposition worked quite well. And then if you combine them, lo and behold, you get 3x squared negative 13x minus 10, which was the original problem. So we know that our factoring here, our final answer, is correct with that nice little 30-second check that we did there. Anyway, if you have any more questions on this stuff, please feel free to reach out and ask. I know I went kind of quick when I factored out x from here, and when I factored out negative 5 from here. I know I went quick through that. I did that intentionally because that is older material, and I just don't have the time in this video to cover that. But if you do have any questions on that, please feel free to reach out. I have no trouble at all making. I could make a video on it, or I could just discuss it with you guys one-on-one. Anyway, that being said, I hope you enjoyed this video and that you're having just a blast with this stuff. Like I said, this is where math gets really kind of cool and magical. So I hope you're enjoying it as much as I am. Really, really fun stuff. That being said, I hope you're all doing extremely well and staying safe. Take care.